So in the previous screencast we saw why the market is so popular among economists. It can generate the maximum welfare simply by implementing a market mechanism. Now the assumptions under which we get this result are not always true in the real world, and we're going to look at a number of reasons why the market may actually fail to generate maximum welfare. And the first reason that we're going to be looking at is the income distribution. The idea here is that some people may have very high utility to get a good, but they simply may not have the money to buy it. So we're going to make two factors now. So we're going to have valuations as we had before. And again, we're going to use the TensorFlow library to generate these. So we're going to generate these from a normal distribution. Again, we're going to assume there are 50 consumers. We're going to draw from a normal distribution with a mean of 10 and a standard deviation of 2. Just to make sure that the vector looks a bit nice, we do this. And then we have incomes, which we didn't have before. So these we're going to generate as well from a normal distribution. We also need 50 of these, and let's say that these come from a normal distribution with mean 8 and standard deviation 2. So now I'm going to define three functions. The first one is afford, which is a function of the price. And it's basically going to return whether or not an individual in the vector incomes has an income bigger than P. Yeah, so if the agent has an income bigger than P, at least he can afford the good. And then we're going to look at willingness to pay. So somebody may be able to afford the good but actually don't want to buy it because utility is lower than the price. So these are people whose utilities are bigger than the price. So these are people who are willing to buy, but they may not be able to buy if their income is not big enough. So we have a new demand function here, let's call it demand 2, which depends on price. And this one returns the sum of people who can afford the good at the price P and who are willing to pay the price P for these goods. Yeah, so just to illustrate, the function afford now doesn't return a number, but it returns a Boolean mask. Yeah, so these are all the people who can afford to buy a good at the price of 10. Yeah, so everywhere where it says true here, these people can actually afford to buy the good. So to illustrate what the difference is with what we did before, let's again define the range of P as being numpy range 15. So we're going to plot first what is actually called demand before, so that in this case is willingness to pay as a function of P. For P in range P, so this is now willingness to pay. It's no longer demand, because you need both the willingness to pay and the income before you can buy a good. So the second thing we're going to plot is actually our new demand function. For P in range P, and we're going to plot this against range P, and the label here is going to be demand. Just to know which curve is which, we also plot the legend. And as you can see, willingness to pay here lies above the demand curve everywhere. And the reason is that willingness to pay is just utility, but for demand you need to have both a high enough utility to buy and the income to buy. So you need to satisfy two conditions, while in the previous screencast you only need to satisfy one condition, which was that your willingness to pay or your utility was above the price. So now we can define a new excess demand function. Let's call it excess demand 2, which is a function of P. And basically what the returns is demand 2 as a function of P minus the 10 units that we can still allocate among our 50 consumers. So then the price, the equilibrium price in this new system, again we're going to use SciPy optimize fsolve. Now we're going to apply it to excess demand 2, and our initial guess is that its equilibrium price will be around 10, and we're going to see what price 2 is going to be. And we made a mistake here. So we should have said define excess demand, and as you can see the new equilibrium price is now around 9. So with this new equilibrium price, so the equilibrium price is lower now because it's the intersection point of the 10 units that we had here with the lower demand curve, not with the willingness to pay curve as we did before. So that would have given us a equilibrium price of around 12, which we found before, and now we find one around 9. So now if we calculate welfare, so welfare under the new system is again the sum of valuations, but now we're going to have two Boolean masks. The first is whether people can afford to buy the good, and the second is whether they are willing to pay a price of price 2 for this good. And then we can see what welfare 2 is, and it's now 110, which is lower than it was before, and therefore the market no longer generates the maximum possible welfare that can be generated in this economy. And the distortion here is that people need to have both the willingness to pay, the utility, like before, but now they also need to have the money to buy the good, and they may not simply have enough income to buy the good, and therefore if we can allocate based on utility only, which is not easy in the real world, but if we could do that, we could actually do better than the market outcome. Just a quick check to see why this works. So what we have here is valuations, which is the vector of our utilities. We multiply this with this Boolean mask of 0 and 1s for everybody who can afford a price equal to price 2. And then we multiply this again with a Boolean mask, 0s and 1s, of everybody who's willing to pay a price of price 2. So when you multiply these two, the only people who are going to buy are the ones who have a 1 in afford and who have a 1 in willingness to pay. If either of these two is false, so we have a 0, then this person will actually not buy the good.